Of test, statistic, and population mean. Module 6, Statistic and Probability. What is test statistic? A test statistic is a numerical value calculated from sample data during a hypothesis test. It serves as a basis for making inferences about the population parameter under investigation. The test statistic quantifies the extent to which the sample data supports or contradicts the null hypothesis. Importance of test statistic in hypothesis testing. Test statistics provide a standardized measure that allows for the comparison of sample data against theoretical distribution. They help determine the likelihood of observing the sample data under the assumption that the null hypothesis is true. Test statistics enable researchers to make informed decisions about accepting or rejecting the null hypothesis based on the observed data. They play a crucial role in quantifying the strength of evidence against the null hypothesis and in drawing conclusions from researcher findings. The test statistics facilitate the replication and verification of research results, contributing to the credibility and reliability of scientific investigations. Population mean. The population mean, denoted by U or mu, represent the average value of a numerical variable within an entire population. It is calculated by summing up all individual values in the population and dividing by the total number of observations. The population mean serves as a central measure of tendency, providing insights into the typical or average value of the variable of interest across the entire population. Understanding the population mean is essential for making inference about the characteristic of a population and for drawing conclusions based on a sample data. In statistical analysis, population mean is often used as a benchmark for comparison with sample means and for hypothesis testing. So this is the formula for calculating population mean or MU. Mean equals ano siya? X or N. U or MU is the population mean. Kana siya, X denotes the sum of all individual values in the population. N represents the total number of observations in the population. In short, the formula involves summing up all individual values in the population and then dividing by the total number of observations to obtain the average value. Hypothesis testing. Hypothesis testing is a statistical method used to make decisions about population parameters based on sample data. It involves comparing the observed sample results with what would be expected under a null hypothesis, which typically represent the absence of an effect or difference. Here are the key components. First is the null hypothesis or H0. The null hypothesis states that there is no significant difference or effect. It serves as the default assumption to be tested against. Number 2 is alternative hypothesis or H1 or HA. The alternative hypothesis suggests a specific effect and difference. It represents the researcher's hypothesis or the claim to be tested. Significance level or A. The significance level represents the probability of making a type 1 error, rejecting a true null hypothesis. Commonly chosen values include 0.05 or 0.01. Test statistic. A test statistic is a numerical value calculated from sample data that serve as the basis for making decisions about the null hypothesis. It quantifies the strength of evidence against the null hypothesis. P-value or critical value. The p-value is probability of obtaining the observed sample result or more extreme, assuming the null hypothesis is true. The critical value is a threshold value beyond which the null hypothesis is rejected. These are the steps in hypothesis testing. First is the formulate hypothesis, define the null and alternative hypothesis based on the research question. Second is choose significance level. Select the significance level or A to determine the threshold for rejecting the null hypothesis. Select test statistic. Choose an appropriate test statistic based on the type of data and hypothesis being tested. Number 4. Collect data. Obtain a sample from the population of interest. Number 5. Calculate test statistic. Compute the test statistic using sample data and relevant formula. 6 is determine critical value or p-value. Determine whether to reject the null hypothesis based on the test statistic and the critical value or p-value. Number 7, make decision. If the test statistic falls beyond the critical value or if the p-value is less than A, reject the null hypothesis, otherwise fail to reject it. Number 8, draw conclusion. Based on the decision, conclude whether this is sufficient evidence to support the alternative hypothesis. In short, for the summary, hypothesis testing enables researchers to make inferences about population parameters, assess the significance of research findings, and draw conclusions based on sample data. It is a fundamental tool in scientific research, data analysis, and decision-making processes across various disciplines. Computing test statistic for population mean. Step by step of computing test statistic for population mean. First is to formulate hypothesis. Null hypothesis or HO population mean equals a specific value or alternative hypothesis or H1 or HA. Population mean differs from the specific value. Second is select significance level or A. Choose the significance level to determine the probability threshold for rejecting the null hypothesis. Number 3 is collect sample data. Obtain a random sample from the population of interest. Number 4, calculate sample mean. Sum of all values in the sample and divide by sample size or n. Calculate sample standard deviation or S. Compute the standard deviation of the sample data if the population standard deviation or O is known. You can skip this step. Determine standard error or SE. If the population standard deviation or O is not, use SA equals O and SA equals NO. If the population standard deviation is O is unknown, estimate it using the sample standard deviation or S, then calculate SA equals SN, SA and NS equals NS. Compute test statistic or ZOT score. If the population standard deviation is known, use Z equals X negative prime or negative minus U or mean SAZ equals SA X negative minus mean. If the population standard deviation is unknown, use T equals X minus or negative minus mean SE T equals SE X negative minus mean. Determine critical value or p-value. Based on the chosen significance level, find the critical value from the standard normal Z or T distribution with appropriate degrees of freedom. Alternatively, calculate the p-value associated with the test statistic. Make decision. If the absolute value of the test statistic exceeds the critical value for a two-tailed test, or if the p-value is less than A, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. Lastly is draw conclusion. Based on the decision, conclude whether there is sufficient evidence to support the alternative hypothesis. Interpret the result in the context of the research question and the chosen significance level. Formula and calculations for computing test statistic for population mean. Formula for sample mean. Mean equals, ana siya, I equals 1, N, X, I, N, X equals N. Gusto mo na siya. Where xi represents individual values in the sample and N is the sample size. Formula for sample standard deviation. So, mo na siya ang formula, ana. Where is x negative is the sample mean, xi are individual values in the sample, and n is the sample size. Formula for standard error, SE, if the population standard deviation is known, mo na siya ang yung formula. If the population standard deviation is unknown, mo pa ni siya ang formula, which O is population standard deviation if known, S is the sample standard deviation, and N is the sample size. Formula for test statistic, Z or T-score. If population standard deviation is known, mo na siya. If population standard deviation is unknown, mo niya ang formula. Where X is the sample mean, U is the hypothesis, population mean, and SA is the standard error. Calculation of critical value. Based on the choosing significance level, find the critical value from the standard form, Z or T distribution with appropriate degrees of freedom. Calculation of p-value. Determine the probability of obtaining the observed sample results, or more extreme assumption the null hypothesis is true. Decision making. If the absolute value of the test statistic exceeds the critical value for a two-tailed test, or if the p-value is less than a, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. So here are some examples. So example 1, compute the z-value giving the following information. Use one-tailed test and 0.05 level of significance. So ang mean na to is 71.5, then ang U na to is equals to 70, then ato ang division is equals to 8, then ato ang sample size is equals to 11. So, maundid dayo na siya ang answer. And here's the other example for it. The government claims that the monthly expenses of a Filipino family with 4 members is 10,000. A sample of 26 families' expenses has a mean of 10,900 and the standard deviation of 1,250 pesos. Is there enough evidence to reject the government's claim at A equals 0.01? So, mananday ni siya, inanyonin mo siya pag-solve, and then ang answer ana is the computed t-value is 3.671. So, here are the key points. Here are the key points. Hypothesis testing basics, definition of hypothesis testing, importance of testing hypothesis in statistical analysis. Number 2 is components of hypothesis testing. So there are 6 hypothesis testing for population mean. There are 3 critical concept and terminology. There are 5. Yes, 5. Application and interpretation. There are 3 as well. The conclusion is hypothesis testing. Hypothesis testing is a fundamental statistical method used to make inference about population parameters. It provides a systematic framework for evaluating hypotheses, assessing the significance of results, and drawing valid conclusions based on sample data. So these are the importance of understanding test statistic and statistic and probability. Foundation of statistical analysis. Test statistics serve as the backbone of statistical analysis, allowing researchers to draw conclusions and make inference about population parameter based on sample data. Validity of research findings. Understanding test statistics ensures the validity and reliability of research findings by providing a systematic method for evaluating hypotheses and assessing the significance of results. Decision making. test statistics plays a crucial role in decision making processes across various fields, including science, healthcare, finance, and business. They help stakeholders make informed decisions based on statistical evidence. Quantifying evidence. Test statistics quantify the string of evidence against null hypothesis, enabling researchers to determine whether observed difference or effects are statistically significant and not merely due to chance. Comparison and generalization. Test statistics facilitate comparisons between sample data and theoretical distributions, allowing researchers to generalize findings from samples to larger population. Effect size estimation. Test statistics such as coherence, D, and effect size estimation provide measures of the magnitude of observed differences or effects, helping researchers assess the practical significance of research findings. Research certification and verification. Understanding test statistics is essential for replicating and verifying research findings. It enables researchers to reproduce analysis and confirm the robustness of results across different samples or studies. Statistical literacy. Knowledge of test statistics to enhance statistical literacy among researchers, practitioners, and decision makers, empowering them to critically evaluate research studies, interpret statistical findings, and make evidence-based decisions. Enhance problem-solving skill. Proficiency is test statistic fosters critical thinking and problem-solving skills, allowing individuals to analyze complex data, identifying patterns, and draw valid conclusions in various analytical contexts. Continuous learning and improvement. As statistical methods evolve and new techniques emerge, understanding test statistics enables individuals to stay abreast and advancements in statistical analysis, fostering continuous learning and professional development. That's all. Thank you.